Okay, so good evening. I hope I'm audible to you and let's get started. So today we are going to learn about turning effect of a force. It is one of the important lesson for your O level as well as for your second term grade 10 exams. So it is a very important lesson, at least for your second term. For the grade 10 second term, at least you can score about 7 marks in this lesson, because especially this is a lesson where you will be focusing more on physics. Okay. So this lesson has so many calculation. Today we will practice more calculation, and I will make this lesson easy for you to understand how the lesson is working, right? So this lesson is interesting if you are going to view at a point as the easiest way, okay? So let's talk about the lesson. Before that, I hope you're ready with the lesson. And also, I have provided you a model question. It's just a normal model question where I have picked from your term papers, from your second term papers. I picked some of the question I have provided you. So once after I complete the lesson, I will complete this lesson completely. And once the lesson has been completed, please try to do the model question. If you find any difficulty in the model question, you can contact me anytime. I will be able to clear your doubts. Okay, right. So let's get started with the lesson. So the lesson is about turning effect of a force. Turning effect of a force. So I know some of you all find difficulty in learning this lesson because it's calculation. So not everyone is facing difficulty, but some of them. To make sure that you understand the lesson clearly, I will move with the basics to advance. Okay. So listen to me carefully. This is an interesting lesson and I will try my best to make it understandable more. Okay. Right. Listen to me. Now, in this lesson, we should have some ideas related to the resultant force. Can you remember in Unit 9 of your grade 10, you studied about what? You studied about resultant force. So, some knowledge of resultant force is very important for this lesson. And also, you studied in Unit 2 about what? You studied about some distance, displacement. So some ideas about it you need it, but not much about it. But you should have the idea about the lesson 4. It's about the lesson force. It's about the lesson force. So combination of the resultant force and combination of the lesson. What is that? We studied about the Newton's law. So you have to just combine both of them and you have to get an idea that is going to be the lesson turning effect of a force. So in this lesson, you will be learning from the basics. So let's say, for example, now you have an object. Okay. So let's say you wanted to push the object. And what are you supposed to do? What are you supposed to do? Now just say, for example, now this is the object. And if I just push the object, will the object move according to the science we studied? According to the science, if I just push the object, will it move? So that means if I just give a small force, will it move? No. So always remember, if an object has to move, there should be resultant force. Not just the force, they should have the resultant force. They should have the resultant force. So if an object has to move, they do not need a normal force, they need a resultant force. So you have to make sure that if you get any question, for example, for the MCQ, so they can ask you, an object is moved because of what? Resultant force. Is it because of a force? No. Force can be high, it can be low, but sometimes the object can move, sometimes the object will not move. But what you have to understand is the final force that is given after you are pushing or pulling, that you call it as what? Resultant force. Say, for example, now there is a wheel. Let's say there is a wheel. Okay, now say if I need to rotate the object and if I apply the resultant force, is that enough? No. By applying a resultant force, you can move the object in this way. You can move the object. But if you wanted to rotate an object, you need another type of force. You call it as moment of force. You call it as what? Moment of force. So what do you mean by moment of force? So moment of force means you are giving a force to an object, in the center. It is fixed from the can't give a resultant force. The only thing that you can give is what? Moment of force. So it is a type of force. Now, can you remember you studied in Unit 5 frictional force? What do you mean by frictional force? So frictional force in the sense what? So frictional force means a force that opposes the relative motion, that will not let a motion to move. So like that means what do you need to understand? So you understand that frictional force is like a barrier for the relative motion. So same like that, another type of force that you are learning to rotate an object at a fixed point. So what do you call that as? You call it as what? You call it as moment of force. So moment of force is a force that is used to rotate an object at a fixed point, that you call it as what? Moment of force. Clear with that? So now listen to me carefully. Listen to me carefully. If you got any doubts, once after I explain you, I will ask you whether you understood or not. At that time, you can send me a chat. You can send me a chat via Zoom. In case if you don't have the chat option in the Zoom, sometimes some people, they have a problem with chatting in the Zoom, right? Sending a message. So in case if you're unable to do that, you can send me a WhatsApp message, because I can view slightly, so that if you have any doubts, you can send me a WhatsApp. So I'll just write down my WhatsApp number here. Like in case if you're new to the class, if you don't have my contact, yes, I will explain back again. So this is my WhatsApp number. In case if you are unable to chat through the Zoom, you can. Okay, so someone asked me to explain again. I will explain you back again, because this is an important physics lesson. Listen to me. So now, listen to me. Now, what you need to understand is, say for example, now you have a object. The only force that I can give for this object is a resultant force. Now it is a type of force, right? Resultant force is a force that will allow the object to move. Now say for example, the object which is already moving. Let's say an object is already moving and I wanted to stop this. I wanted to stop the object. So what I will do? I will be applying the frictional force by applying a brake. I will be applying a frictional force by applying a brake. So that means resultant force will, what will it do? It will allow the object to move. But frictional force, it will not allow the object to move. Now you can see this is one kind of force. This is another kind of force. Same like that. Now you have an object and you wanted to rotate this object. You wanted to rotate this object. At the same time, this object is fixed at a point. It is fixed at a point. It is fixed, but still it can rotate. So for that, I can't apply resultant force. I can't apply frictional force. The only force that I can apply to rotate this object at a fixed point, you call it as force. So moment of force is only force that will allow the object to rotate at a fixed point. So that we call it as what? We call it as the moment of force. So if you wanted to move, an object, we apply resultant force. If you wanted to stop an object, we apply frictional force, especially like when you are applying a brake. And then if you wanted to rotate an object, the only force that you will be providing is what? Moment of force. Clear with that? Got the idea? Am I lagging? Am I lagging? Let me know if I am lagging. Okay, so Salha, just check your side also. Here also it's raining. That's the problem. So since it's raining, we can have sort of coverage problem, but it's okay. I'll try my best to have the better connection. Okay, right. Okay, so we get it as what? We call it as the moment of force. So moment of force is a force that we apply to rotate an object. So now you got an idea what is the moment of force, right? You got an idea what is the moment of force. So let me tell you something. Let me tell you something. Now say for example, now you have an object like a rod. Let's say you have a rod. You have a rod, and this rod is fixed at a point. This rod is fixed at a point. So the object that is fixed at a point, we call this as axis of rotation. So what do we, let's say this duster is fixed from here. That means you can swipe like this. You can open and close, but still this object is what? It is fixed at a point. So the object where it is fixed at a point, we call it as what? Axis of rotation. We call it as what? Axis of rotation. Now say for example, now let me take the same example here. Now say me, if I need to move this object, let's say if I wanted to move this object, if I apply a force in this direction, let me mark this as force 1. And if I apply a force in this direction, in which direction of the force will I be able to move the object or rotate the object? Let me show you. Let's say this is the duster, and the duster is fixed from this point. It is fixed from this point. Okay, it is fixed from this point. And then let's say if I am giving a force in this direction, can I rotate this object? Yes, I can rotate. But if I'm giving a force at this direction, can I rotate this object? I cannot rotate this object. So what do you need to understand from here is, now to rotate an object, you need a force, right? You need a force. What is that force? We call it as what? Moment of a force. So rotate an object, you need to apply a force that you call it as what? Moment of force. So you said that when I'm applying a force at the direction of this F2, the object didn't rotate. But when I'm applying a force at this direction, the object rotated. So which means, what can you see from here? What can you see? Like, can you see you are getting a direction like this? You can see that the force is perpendicular. Can you see it comes as a 90-degree when I'm having a force in this direction? The object is in the horizontal. So you are having a force at the vertical. So can you see that the force that I'm applying is perpendicular to the axis of rotation? It is perpendicular to the axis of rotation. So according to the moment of force, according to the moment of force, what do you need to understand? What do you need to understand? Let's say if I wanted to rotate this object is fixed at a point. So the point, look here, the point where the object is fixed, we call it as axis of rotation. Okay. And also, listen to me, I am going to apply force in two directions. One direction like this, another direction from this way. So let's assume that the object is the duster. So if I am giving the force in the direction of F1, can I rotate the object? Yes or no? Can I rotate the object? Yes or no? Yes, I can rotate the object. But if I am applying a force in the direction of F2, can I rotate it? Like if I'm giving it straight, will I be able to rotate it? No. So from this, what did we understand? From this, what did we understand? So if I am applying a force that is directly to the direction of the axis of rotation, I can't rotate the object. But if I'm applying a force that is perpendicular, what do you mean by perpendicular? Perpendicular in the sense we say the 90 degree. 90 degrees. So when you are applying a force that is perpendicular to the axis of rotation, we will have the moment of force. So if you have the moment of force, you can rotate the object. Did you understand? Did you understand? It's like a condition. It's like a condition. Okay. If you wanted to have a moment of force, yes, you need to have a force that is acting perpendicular to the direction of what? Perpendicular to the direction of the axis of rotation. So that is what you call it as what? Moment of force. Very easy if you understand this concept. Okay. So what is the moment of force? Moment of force is a product of a force. Product. You studied this word product in maths. Product in the sense, always remember we say multiplication only, we call it as product. So when it comes to the product of a force, multiplication to what? Perpendicular distance from this point to this axis of rotation. Let's say I am giving a force at this point. From this point to this point, I should have a distance. I'm having a distance from this point to this point. I'm having a distance. So when I'm having a distance from this point to this point, I call this distance as perpendicular distance to the axis of rotation. I call this as what? Perpendicular distance to the axis of rotation. So that means from the place where I give the force to the place of the axis of rotation, there is a gap, right? So that's the distance to the axis of rotation. So which means, what is our equation? Our equation is moment of force is equals to force into perpendicular distance to the axis of rotation. So that is going to be our equation. So if I wanted to find the moment of force, what is my moment of force? My moment of force is force into distance. So you can, instead of writing the whole equation, you can take it as F into D. You can take it as what? F into D. So this is going to be the equation to find the moment of force. So what is the unit you measure the force? Newton. What is the unit you measure the distance? Meter. So this is going to be what? This is going to be the unit you measure the moment of force. Newton meter. The moment of force, the unit for the moment of force is going to be what? Newton meter. So let me explain you one more time before I go to the next part. So listen to me carefully. Listen to me carefully. So you have to rotate an object. So if you wanted to move an object, we need resultant force. If we wanted to stop an object, wanted to rotate an object, we need to have a different kind of force. We call it as moment of force. Moment of force. So in this moment of force, we have two conditions. If a moment of force has to take place, there are two conditions. The first condition is object should be fixed at a point. Object should be what? Fixed at a point. So if the object is fixed at a point, what do we call it as? What is the name that is given? We call it as what? Axis of rotation. We call it as what? Axis of rotation. Then to have a moment of force, that means we need to have a force, right? So what do is we give force in two directions. So I'm going to give one direction force from here, and I'm going to give a force another from another place of direction from here. So then I understood that in the force one direction, the direction of the force in the F1 will rotate the object, but the force in the direction of F2 will not rotate the object. So then we understood that to have a moment of force, the force has to be what? It has to be perpendicular to where? Axis of rotation. So therefore, we got an equation for the moment of force. What is the equation? Moment of force is equals to force into perpendicular distance. That means the point where you apply the force to the point of axis of rotation from these two gaps, we call this as distance. What is that distance? We call it as perpendicular distance to the axis of rotation. So which means initially we can take the equation for the moment of force is what? F into D. So force is measured by Newton and distance is measured by meter. So what is the unit you measure? What is the unit you measure the moment of force? That's going to be Newton meter. If you have understood until here, then that's fine. Did you get the idea? Did you get the idea? Yes. Did you get the idea? So this is the small introduction part. Slowly, I will introduce you the equation. I'll teach you how to calculate. It's interesting if you understand from the beginning. Okay, right. Now look here. Now let me say you something. Now listen to me. Now imagine. Okay, now this is the door. Imagine. Now example, you have the door. Okay, you have the door here, and from here only the door is fixed. This is our door, your room door. This is your room door, and here only it is fixed. Okay, now say for example, now if let's say, now this is the door, right? Now if you look like this is the door. Now if I apply a force in this direction, let me mark this as F1 and let me mark this as F2. And you can answer me, say me, if I apply a force like this, and if I apply a force in the direction of F2, can you tell me in which direction does the door will rotate? Is it in the direction of F1 or is it in the direction of what? It is in the direction of F2. In which direction will it move? Very good. In the direction of F1. Why did you say it as F1? What is the reason? Because according to the moment of force, the force has to be applied, but the force has to be applied perpendicular to the what? Perpendicular to the direction of axis of rotation. So this is the axis of rotation. So now you understood that's where how the door is getting open and closed. So this is what you understood. Now let me tell you something. Now just imagine you see the doorknob. Let's say this is the door knob. This is the knob, right? If you take your door and you have the doorknob here, and let's say you have another doorknob here. So one is at the edge here, one is at the center. Now let me tell you something. Now you might have noticed, now let's say this is the door, right? And let's say your door is fixed like this. The door is fixed to the wall. So this is going to be the axis of rotation. This is going to be the axis of rotation. And let's say most of our home, we have the door knob here, isn't it? Let me mark this as A. And imagine, why don't we have the door knob somewhere in the middle here? Why don't we have? Have you ever tried to open the door from the center, like without the knob? Like, have you ever tried to close, or have you ever tried to open from the center? You might have tried, but you might have felt difficult to open. You might have felt difficult to open. So let me tell you, why do we have the knob at the edge, but why don't we have the knob at the center? So let me explain you what is it about. Let me explain you. Now, can you tell me, can you remember I said if you are giving a force from this particular direction, and if you are giving a force from this particular direction, from the place where you give the force to the axis of rotation, it as perpendicular distance. That gap only we call it as what? Perpendicular distance. So remember, if the perpendicular distance is high, if the perpendicular distance is high, you will understand the amount of force that you give will be less. That means, say, if you are feeling easy to open the door, when you open from the edge, when you open from the point A, if you are feeling easily open the door, that means the force is less. Why? Because the perpendicular distance is high. But if I have the knob at the B, and if I'm trying to open the door or close the door, if I'm feeling difficult to open, what's the reason? Because my perpendicular distance is less. So who is the reason? What's the reason here? That's the perpendicular distance. So if the perpendicular distance of the object increases, the force will be less. But if the perpendicular distance of the object decreases, the force will be high. So which means that's the only reason you find the knob of the door at the edge. On the other end, you have the axis of rotation here. From the other point, you will have the knob here. Why? You have to feel easy to open. So who is affecting here? What is the main reason? Perpendicular distance. I will prove you. I will prove you how this is working. So remember, moment of force is constant. Moment of force is constant in the sense in your exam, they will provide you moment of force. They will give you the moment of force, okay? By using that, you have to find the force. They will provide you the moment of force. By using that, you have to find the forces. You have to find the forces. I'll show you how it is, but did you understand why do we have the knob at the edge? Did you understand why do we have the knob at the edge? I'll explain you. Don't worry. I'll explain you. You understood, right? Okay. So someone asked me to explain. I'll explain very shortly and the way you understand. Now, this is our door. This is our door. Okay, so this is our room door. Imagine like that. And our room door, it is fixed where? Where is it fixed? Part of a wall, right? We call this fixed part as an axis of rotation. Axis of rotation, isn't it? And then we find the door knob is at this corner. If this is the axis of rotation, the door knob is at this corner. And then this is how we push the door, right? We give a force and this is how we push the door. Why are we giving the force in this direction? Because to rotate an object, to have a moment of force, we are supposed to give a force which is perpendicular to what? Axis of rotation. From this point to this point, from the point where you gave the force to the point of axis of rotation, we call this as what? Perpendicular distance. We call this as what? Perpendicular distance, isn't it? So some people, like even scientists, they were thinking, why don't we have the knob at the center? Let me mark the knob as B. This knob as a B. So why do we have like universal thing, like we all are us having the doorknob at the edge but not in the center? Why is that? The reason is when you take the perpendicular distance from here to here, we can say the perpendicular distance is high. So when the perpendicular distance is high, with a small tuck, you can open the door and you can get inside the room. So that means the force is less. Then if I have the force, if I'm applying the force at the B, from here to here, what is happening? Look at the gap becoming small. That means the perpendicular distance is decreasing. So when the perpendicular distance is decreasing, what is happening? The force is increasing. So that's why whenever you try to open the door from the center, let's say there is no knob, but you try to open the door from the center, you will feel very difficult to open. Why? Because the perpendicular distance. So simply understand who is playing a major role here. Why are we having the knob at the edge? Because of the perpendicular distance. If the perpendicular distance is high, the force will be less. If the perpendicular distance is less, the force will be high. So that is the main reason that we have the knob of the door at the edge. I will prove you in a calculation wise, okay? So let me tell you, the moment of force is there, right? In your exam paper, moment of force, they will provide you. They will provide you the moment of force. They will provide. And remember, it is constant. Remember my word, it is constant. Constant means what? It will never change for a certain question. For a question, they will give you a moment of force as Like they will give you a certain moment of force, and for the throughout the question, you are going to use the same moment of force only. Let me show you a question. Let me say the moment of force of the door. Let me say you, the moment of the force of the door is 100 Newton meter. 100 Newton meter. And let me say you that from A, so let me say you, let's say 25, the B to the axis of rotation, let me say it is 5 meter. So you can see that. Now, how can I find the force 1? Let me say they're asking you to find the value of force 1 and they are asking you to find the value of force 2. So how are we going to find the value of force 1? So let me put the heading as force 1. What is our equation for moment of force? Moment of force equal to what? Force into distance. Do we know the force? We don't know. Put as it is. And then D, what is our whole distance? What is the whole distance from A to the axis of rotation? That is 25. And what is the moment of force that they have given? 100. So what are we supposed to do? The 1 in the multiplication. And then you find the value of force is 4 Newton. 4 Newton. And then let me find the force that I have to apply at the F2. And here, and then we can write 100 is equals to F into, what is the value? 5. So F into 5. So you take the 5 to the other side, you divide it. What's the value? Force is equals to 20 Newton. Now tell me, in which side? Now this I have proved you. In which side I have to apply the high amount of force? So here I have to give 20 Newton. And here I have to give only 4 Newton. So I proved you that when the perpendicular distance is high, the force is less. That's the example 1. And when the perpendicular distance is less and the force is high. So can you see? Did you understand this? Did you understand this? I'll explain you the question. Listen to me. Listen to me. Just understand the perpendicular distance is high in the sense the force will be less. That's why the knob of the door is fixed at the edge of the door, not at the center, not closer to the axis of rotation. Why? When the perpendicular distance is high, the force is less. The force is less. And if the perpendicular distance is less, the force is high. The force is high. Okay, so now what do you need to understand? What do you need to understand? So if the perpendicular distance is high, I told you the force is less, right? So say for example, from the axis of rotation to the point A, from the axis of rotation to the point A, the value is 25 meter. The value is 25 meter. That means the perpendicular distance from axis of rotation to the point A is 25 meter. From the point B to the axis of rotation, the value is 5 meter. So just to prove that, remember the moment of force they will provide in your exam paper, and they will say that the, they will say that the moment of force is constant. It will never change. The moment of force will be constant for both of the forces that you are applying. So what is our task? Our task is to find the amount of force that is applied at the point A as well as the point that is applied at the point B. So what did I do? I took the force 1 and I wrote the equation. Force moment of force is equals to force into distance. 25, take it to the other side. You divide the force that you are applying at the F1 is what? It is 4 newtons. You did the same thing on the other side and you found that the value of the force B. The value of what? The value of the force B is what? 20 Newton. So what did you understand simply? So simply what I showed you in the equation, I proved it with the calculation. Clear? Understood? Got the idea? I will show you more examples. I'll show you more examples. It's because of raining, I guess it is lagging. So sometimes I do not understand, why it's lagging, because when I can see the connection is stable, but still there can be coverage issue. So if I'm lagging, let me know. I will just take 2-3 minutes and then I will start again, because whatever it is, it's going to be the same. Okay, am I clear right now? Am I clear? Okay, right. Okay. Thanks for confirming. Right, okay, look here. Okay, look here, look at the board. So let's say, for example, now what is the first factor did you understand from a moment of force? From the moment of force, you understood that the perpendicular distance is there, right? The perpendicular distance is the main factor that is affecting the moment of force. If the perpendicular distance is high, force is less. If the perpendicular distance is less, the force will be high. So that you have to fix it in your mind, okay? Right, now let me say you something. Let me tell you something that you needed to understand. So listen to me very carefully. Yeah? Some questions you have to understand. Now let's say for example, now you have an object. You have a rod like this, okay? You have a rod and this rod is fixed at a point. This rod is fixed at a point. The nut of the object is fixed loosely. That means the nut of the object is fixed loosely, not tightly. Yeah? Imagine this is fixed loosely, like this, like loosely. It can be rotated easily, okay? Now you wanted to rotate this object and imagine you are going to, now this is a 1 meter rod. This is a 1 meter, 100 centimeter. 100 centimeter. So now listen to me. Now you are going to apply a force from this edge. Let me mark this as A. And you are going to apply a force from this edge, like closer to the axis of rotation. So let me mark this as force B. And let me mark this as force A. That means I'm applying a force at A and applying a force at B. So when you have a particular situation, the object will need a particular need of force, right? To rotate, they need a force. So imagine they have provided the value of the force. Let's say they have provided the value of the force A as 200 Newton. Okay, so for 1 meter rod from this edge, what is the value? What is the value? Like they have provided you the force, right? They have provided you the force and they have provided you the distance. Now in the exam, if they ask you as a Roman number 1, the first question, find the moment of force. Simple. What's the equation? F into D. So what is the force? 200. And what is the distance? The whole distance is what? From this point to this point, the whole distance is 1 meter. So that means your moment of force is going to be Newton meter. Newton meter. Simple. Some people, they don't understand. They forget. They get scared because since they have done lots of hard question, they will forget the basic things. So that's what I'm telling you, how to do the basic stuff. Then again, they will say from this point to this point, they have given you the distance as 20 centimeter. Let's say they have given it as what? 20 centimeter. Now listen to me carefully. If they have given in centimeter and if I wanted to convert into meter, what am I supposed to do? What am I supposed to do? Should I multiply by 100 or should I divide it by 100? What should I do? Should I multiply it by 100 or should I divide by 100? Very good. I have to divide by 100. So instead you are dividing and you are getting the answer. Let me show you a easiest way. So let's say they have given you a question number 2. Find the force at FB. So you have to find the force at where? FB. Simply, you found the moment of force. What was my idea? Moment of force always, it is constant. I said moment of force always constant. Let's say if you have one object, wherever you apply the force, the moment of force will be always constant. So if you find the moment of force once, you don't need to find it again and again. That one moment of force will help you to find the answer for the rest of the question. So let's write it. The moment of force is 200. Then what is the force that we have? We don't know. That should be mentioned as FB. Multiplied by, what is the value? That means we say it's centimeter, no? So centimeter has to be converted by meter. So what did you say? You said you have to divide the 20 by 100 to convert it as what? To convert it as a meter. So what I can do is, instead you are directly dividing, take all of them to the other side. So you know, the one who is in the multiplication will come as the division. The one who is in the division will come as the multiplication. So let me write down the equation on top so that you can see. So 200, okay, the one who is in the multiplication will come as a what? Division. The one who is in the division, when you take it to the other side, they will come as what? As the multiplication. So what can you do? You can cancel this 20, you can cancel this 20, and you take this as 1, 1, 0, 10. 10 into 100 is going to be the answer, 1000 Newton. That's going to be 1000 Newton. So see, by one information, you found the moment of force, and then you found the value of the force at the FB. Now, did you understand how the question is created? Did you understand how the question is created? I'm showing you a simple way, step by step. I'm practicing you to do questions more with me. I will give you more questions. You will practice more with me. The more you practice, the more you can do questions and you will feel more interested to do. Okay. So this is an example. Okay, so now what happened to the force? Initially, when you gave the force at the A, the force is 200. But when you gave closer to the axis of rotation, what happened to the force? The force has increased. So now what did you understand? You need to understand who is the major person, who is the main factor that is affecting perpendicular distance. So you understood that the perpendicular distance is affecting this moment of force. Clear? Understood? This is a simple part of the lesson. Did you understand? This is a simple part. Now, step by step, you are going to the advanced part of the lesson. Clear? Okay, done. Now, can you remember resultant force? Can you remember resultant force? Can you remember resultant force? Now, I'll tell you what is resultant force very simply. Now, when you have a resultant force, like you did a calculation, that means you had an object, right? So if you have more than one object, and if the forces are applied in the same direction, will you add them or will you subtract them? If you have an object and that object is getting more than one force, and what do? And those two forces are in the same direction. No? So what you will do is you will be adding those forces. You will be adding those forces and you will have a force that is going opposite to the direction. So if you have force that is opposite to the direction, will you add or will you subtract them? Will you add or you will subtract them? You will subtract them. So this is the simple idea of the resultant force, right? Same like that. In this lesson, you have resultant moment. What do you have? You have resultant moment of force. Now you will be thinking, okay, what is this direction? So I teach you the direction simply. So the direction is, first, whenever you are taking the resultant moment of force, now we are talking about the rotation, right? So remember the clock. Remember the clock. Let me write it like 12, 6, 9, 3. Now, usually we know that this is how the hands of the clock is moving. We know the hands of the clock is moving in this direction. So, if the hands of the clock or the point of the or needle of the clock is moving in this direction, we call it as clockwise direction. We call it as what? Clockwise direction. But if that goes opposite, let's say, if that goes opposite to the direction, like 1, 2, 3, 6, 7, 8, 9, 12, again it comes like this. No, so this is clockwise. But if that goes in the reverse way, 6, 5, 4, 3, 2, 1, 12, we call that direction as anti-clockwise. So this direction is the clockwise direction. This direction is the anti-clockwise direction. Now you understood the two types of direction. Okay, now, but in the question paper, how does it come? So usually they will give you the common rod. They will give you a common rod like this. They will give you a rod like this, and they will say the rod. They will say this is the rod. Let's say this rod is fixed at a point, and then let's say I am giving a force from this direction. I am giving a force from this direction. Now tell me, is this moving in a clockwise moment or anti-clockwise? If it is moving like this, moving in this direction, what is the direction of the rod? Very good. It is anti-clockwise. But if I am giving a force from the top, if I am giving a force from the top, what is the direction of the rod? What is the direction of the rod? Very good. That is clockwise. That is clockwise. So now you understood the direction of the forces. So now moment of force, the moment of force is there, right? Now moment of force has what? Two types of direction. Now can you remember you studied something called quantity? Scalar quantity, vector quantity. What is scalar quantity? Scalar quantity does not have a direction, but has a moment of a force, has a direction. If they have both the direction and if they have the magnitude, is it a vector quantity or a scalar quantity? Moment of force is a vector or a scalar quantity? What is the quantity of this particular force? It is a vector quantity. Why? Because they have direction, clockwise, anti-clockwise. They have a direction. So since they have a direction, since they have a magnitude, we say what? Newton meter. We take a value, we say a value. So that means they have a magnitude, they have a direction. We call it as what? Vector quantity. So that means a moment of force is what? It is the resultant moment. That means if you have two forces at the same direction, let's say you have two forces at clockwise and clockwise, what you will do? You will add. If you have the forces anti-clockwise and anti-clockwise, you will add. But if you have the forces, if you have the resultant moment of forces at clockwise and anti-clockwise, you have to subtract. I will show you an example. You will get to that and you will understand that, so that I will explain you in a way. So listen to me carefully. Listen to me. I'll show you the example and I will not erase this so you will understand. So look here. Now set of a force and I will give you a question to do it by yourself. Let's say now you have a rod. So this rod is 1 meter rod. It is a 1 meter rod. And this rod is fixed from the center. It is fixed from the center. No, let's say it is, let's imagine Let's say, for example, now I'm applying a force. Let's say, for example, let's imagine I am applying a force from the center. Let's say I am applying a force from the center of this rod. So can everyone tell me, if I am dividing the 1 meter, what will be the value from the center? Like from here, if I'm going from the center, what will be the value? What will be the value? Let's imagine this rod is fixed from the corner. The rod is fixed from the corner. If the rod is fixed from the corner, from this point to this point, can you tell me the value? What is the perpendicular distance? So I told you that 1 meter is equals to 100 centimeter. So if it is half of the 100 centimeter means 50 centimeter, right? But if I wanted to convert the 50 centimeter into meter, it will be 0.5 meter. So that means this, sometimes in your exam paper, they will not give you the value. You should know the center. If you quietly divide equally, if you divide the 1 meter equally, the value has to be 0.5 meter. Again, if I divide it from the center of the 0.5 meter, it will be 0.25 meter. Why? 50 divided by 2 will be 25, right? So you should know how this is working. You should know the basic simple value. So what is the main question here? So I am applying a force from the center. From my force to the axis of rotation, the value is 0.5 meter. 0.5 meter. So this is going to be my force. The force that I'm applying is 300 Newton. I'm applying 300 Newton. Now, can you find the moment of force? Can you find the moment of force? What is the moment of force? Simple. Force into distance, 300 into, like instead you are taking it as 0.5. If you cannot multiply the decimal, take it as 50 divided by 100. Cancel the 0. 3 into 50. How much? 150 Newton. So this is going to be the moment of force. And can you say me the direction? Can you say me the direction of this force? Look at this duster. I'm giving a force like this. The duster is moving like this. The duster is moving in this direction. If the duster is moving in this direction, it's moving in this direction. It is anti-clockwise. So the moment of force is moving towards what? It is moving towards the anti-clockwise. Clear with that? Got the idea? Understood? Right. So now I'm going to teach you the real resultant moment of force. I'm going to teach you what? The real resultant moment of force. So let me show you how that is working to you. Let me show you that. Okay, look here. Look at the board. So let me give you a question to you and I'll show you how to do it. So let me say you have an object and this object is 1 meter rod. It is an object 1 meter rod. And remember, this object is fixed. It is fixed from the center. Let's say the object is fixed from the center. So always remember, I have to bring the object closer to the axis of rotation. So if it is fixed from the center, in the sense, remember this object is what? This object is, like, we have to bring the force closer. Let's say I'm also having a force from here. I'm also giving a force from here. And this is going to be the axis of rotation. This is going to be, the center is going to be the axis of rotation. So what are you supposed to do is, if you wanted to find the direction of the force, what are you supposed to do? You have to bring the force closer to the axis of rotation. You have to bring it closer to the axis of rotation. So let me give you the value here. This is 0.25. And let me give you this as 0.4. 0.4 meter. I'm giving you a random value. And the force that I'm applying here is 30 Newton. And the force that I'm applying here is 50 Newton. Okay. 50 Newton. So now my question here is, now how to find the direction and how to find the resultant moment. I'll show you how to find the resultant moment. Now, first of all, to find the resultant moment, shall we find the direction at the A and shall we find the direction at the B? If you are bringing this one closer and put like this and see, is it clockwise or anti-clockwise? In this side, in the A, can you tell me the direction? Is it clockwise or anti-clockwise? What is the direction of the A? Very good. It is clockwise. So shall we find the resultant moment of the clockwise? What is the resultant moment of the clockwise? Clockwise moment. You can write clockwise into D. So what is the force? 50. What is the distance? 0.4. So 50 into what? 50 into 0.4. So you have to multiply them and then you will get the answer as 20 Newton meter. 20 Newton meter. This is going to be the clockwise moment. And can you tell me the direction of the B? What is the direction of this force B? What is the direction of the force B? What is the direction? Very good. So this is going to be anti-clockwise. Anti-clockwise moment. So if you take the anti-clockwise moment, we know the equation 0.25. 30 multiplied by what? 30 is going to get multiplied by 0.25, which means 7 Newton meter. 7 Newton meter. Now, clockwise and anti-clockwise. Let's say you have an object in the opposite direction. Will you add or will you subtract? If I wanted to find the resultant moment, can you tell me, should I subtract the value or should I add the value? Are they both same direction? Are they both same direction? Very good. Subtract. So what is my resultant moment? My resultant moment is equals to 20 subtracted by 7.5 Newton meter, which means 12.5. 12.5 Newton meter. And can you tell me who is having the highest moment of force? Clockwise. So we will write towards clockwise. So that means this object will move towards the clockwise more. Why? Because clockwise moment has the highest force. Got the idea? Got the idea? Understood? Got the idea? Understood how to find the resultant moment? Okay, can I give you a question to you? Take a piece of paper, back of your book, whatever it is, you can take it, okay? Okay, so someone asked me to explain, dear, so we have to do something like a resultant force like we did in our unit 9. So resultant moment of force means first thing is you have to find the direction of the forces. So they are saying that this object is fixed from the center. So that means if any part of the object is fixed, we call that fixed point as the axis of rotation, right? They have provided you the distance, they have provide you the force. So by just looking now, from always bring the force towards the axis of rotation. So when you bring the force towards the axis of rotation, you can find it whether they are clockwise or anti-clockwise. So if you know, let's draw a clock here. So if the object is moving in this particular direction, we call this as clockwise. If the object is moving in this particular direction, we call it as anti-clockwise. So the first one, A, is moving like this, which means clockwise. And the B is moving in this way, which means it is anti-clockwise. So you can find the moment of force at the clockwise. What is the moment? F into D, 50 into 0.4, 20 Newton meter. And then you can find the moment at the B, 30 into 0.25, 7 Newton meter. Now I told you in resultant moment, if you have an object at the same direction, you can add. If you have it in the opposite direction, you can subtract. So clockwise and anti-clockwise, both of them are opposite directions. So if I wanted to find the resultant moment, should I subtract or should I add? I have to subtract. So 20 subtracted by 7.5 Newton meter is equals to 12.5 Newton meter. So towards which direction? Towards the clockwise direction. Why? Because clockwise has the highest force than the anti-clockwise. Did you understand? Did you understand? Clear? Okay, look here. Can you do this? Find the resultant moment. You have an object that's 1 meter. The whole is 1 meter, and this object is fixed from this side, axis of rotations, until you get correct answer. Okay, and let me say you are getting a force. Let's say this is a force A, and let me say this is a force B. So the force A is 20 Newton, and let's say the force B side to this side is 0.5 meter. From here to here is 0.5 meter. So you have to use your brain, think well, do it. I'll give you only 5 minutes, think. First thing what you have to do, find the direction of both the forces. Find the direction of this person, find the direction. How to find? Bring the force closer to the axis of rotation. Bring the force closer to the axis of rotation. So what you do like this and see whether it's going in this way or that way, find it. And then find the resultant moment here, find the resultant moment here. Then think whether to add or subtract. That's it. Quickly do it so that you will be practicing more questions. It will be easy for you to understand. Try to do it. Don't worry, I'll help you the maximum to do that, because it's a simple lesson. You need more understanding to do that, because you can get any ways. I will show you the maximum how they can even ask you at your exam paper, because sometimes they will ask you from the basics and you have to find it from there. Sometimes they can give you some kind of a question like what do you say, they can give you a question where you have to think a lot, but the question will be easy. So I'll give you all the ways that they could test you. So if you can be patient and if you can try, if you don't try, you don't understand the lesson. The one who tries will get the lesson more. Okay, I'll help you for this one, and next one you have to do it alone. Okay, right, look here, look at the board. If I am taking this force and if I'm taking the both of the force, I can see both of the force are moving in this direction. Can you tell me whether is it a clockwise or an anti-clockwise direction? Is it a clockwise or an anti-clockwise direction? Usually the pin, or we can say the needle of the clock, is moving in this way. So we can say this is a clockwise direction. So that means both of these are clockwise. So you can find the moment of force separately, and you can find the moment of force separately here. So some people, they would have made a mistake. So let's say you are going to find the direction. Let's say you are going to find the moment of force for the B. Let me say you are going to find the moment of force for the B. Some people, they might have taken the value as 0.5, which is wrong. Don't take the distance as it's from the axis of rotation to the force that you are applying only you are supposed to take. So that means what is the perpendicular distance at the B? That's going to be 1 meter. So that means F into D is equal to force is 50 into 1. So that means the moment of force at the B is 50 Newton meter. Then if you're finding at the A, from here to here, no. So that means what is the distance? 0.5. So we can take F into D into 0.5. The answer as what? 10 Newton meter. So both of the A, both of the B are clockwise. What should I do? I have to add. So 10 Newton meter. What is my direction of the resultant moment? That is clockwise. So if you have got this answer as correct, that means you have understood the lesson. Clear? Got it? Say 60 Newton meter clockwise. So if you have understood, if you have done this correctly, you would have got the answer. You would have done the question correctly. I will give you another one. Can you give a try for that? Did you get this one correct? Did you get this one correct? Now, since it's your first attempt, you might go wrong, but let me give you another one. You have to think well, okay? I'll give you more questions. I will give you the answers for that also. I'll show you how to do. And still, you have to get the correct answer, okay? Let me give you like this. Okay, let's say this whole rod is 1 meter. And let's say it is fixed from this side, axis of rotation. Now, this time, no hint. You have to do it alone. Axis of rotation. So, this is the axis of rotation. And let's say the whole rod is 1 meter. And then let's say I am giving a force from this direction. Let me mark this as C. And the C, I am giving a force of 40 Newton. Let's say I'm giving a force of 40 Newton. And then I am giving a force. Let's say this is A. And let's say that's 50 Newton. That's 50 Newton. Okay. And then from the correct center, from the center, I am giving another force. Let's mark this as B. Let's say this is 20 Newton. So I will give you the value. Let's say this is a 1 meter rod. No, the whole rod is 1 meter. From the C to the axis of rotation, let's say it's 0.75 meter. Okay. From the B to the axis of rotation, let's say 0.5 meter. But the whole rod, let me mark it here, meter. Okay, so the whole rod is 1 meter. Resultant moment. Can you find the resultant moment? I'll give you 5 minutes. Can you find the resultant moment? I'm giving you the maximum to practice more so that you will get more idea. 50 Newton, dear. 50 Newton. Sorry. Yeah, give a try. I can see some people have found the answers. Good. And others, I'll give you another 2 minutes. Quickly find it. If I'm lagging, let me know. If I'm lagging, let me know. Dania, you can just check one more time. Okay? Check one more time. Rida also has to check one more time. First, find the direction. First, find the direction. Okay, I'll help you here. I hope I'm audible. Am I having any lagging problem? Am I lagging? Okay, right. Look here. Okay, what you have to do first thing is bring all the forces towards the axis of rotation. So if I'm bringing like this and this way, can you tell me what is the direction of the A and B? Both of them are in the same direction. No? So that means you have the clock and they are moving in this particular direction in the sense this is clockwise. This is clockwise direction. That means A and B is having the clockwise direction. And if you take the C, can you take the C and see? The C is going like this. That means if you take the C is having the opposite what? It is having the opposite direction. So that means C will have the anti-clockwise direction. So what you can do is, first, can you remember you studied in resultant force, like you are having here 20 Newton and you are here having 20 Newton, and let's say you are having a 10 Newton in the opposite direction. First, what you will do? You will add both of the forces at first, because both of them are in the same direction. You will take it as 40 Newton, and then you will subtract with the opposite direction as 30 Newton towards what? Towards the east. So this is how you're doing, right? This is how you're doing, right? Same like that only here also. So first you can take both the forces and you can add them. So simply I'll show you at once how to do it. Clockwise moment. I'm writing in a complete sentence because to make sure you understand. Okay, so force into distance, that is for the A, plus B, force into distance. So what is the force at the A? The force at the A is going to be what? 50. Okay. And what is the distance from this edge to this edge? The whole one is 1 meter plus. And here, what is the force? 20 into 0.5 meter. 0.5 meter. So 50 into 1 is 50. Plus 20 into 0.5 is 10. So what is the clockwise moment? 60 Newton meter. Now what is our anti-clockwise? What is our anti-clockwise value? So anti-clockwise value is force into D. What can you do? Force into D. What is the force they have given you? 40. That is going to be 40. 40 into 0.75. So you're going to take it as what? 40 into 0.75. So 40 into 0.75 is 30 Newton meter. So you found the anti-clockwise value. So if you wanted to find the resultant moment, so clockwise, anti-clockwise, opposite, what can you do? 60 subtracted by 30 Newton meter. Your answer is 30 Newton meter towards the clockwise, clockwise. So that should be your answer. Clear with that? Clear with that? Got the idea? Got the idea? If you have got the answer as 30, you are correct. If you have got the answer at the half as 60, that means you need to improve. Some people, if you have made some mistakes, try to realize. Okay, shall I give you another one? Will you promise that you will take it correct? Will you be able to take it correct? I'll give you easiest way, an understandable way. Yeah. So here it should be fully practiced. Huh? Here it should be fully practiced. Huh? Let me teach you something and then I'll give you another question. Okay. Let me teach you something and I'll give you another question. Remember, in exam paper, they said the rod, let's say the 1 meter rod at equilibrium. They have used the word equilibrium. So remember, if they said equilibrium in the sense, the object it as what? The object at rest. Remember, if they use the word object at rest in the sense, the object is not moving. So let's say they have given in exam paper something like this, and they said that this object is fixed to the roof. It is fixed to the roof. It is what? It is at rest. So let's say I'm having a force here. I'm giving a force of 30 Newton. And this is a 1 meter rod, right? So from this part, 0.5 meter. From here to here, this is the axis of rotation. From here to here, 0.5. Remember, whenever they say the object at equilibrium, remember one particular condition, clockwise moment is always equals to what? Anti-clockwise moment. That means clockwise moment will be equals to anti-clockwise moment. Let's say, for example, you have an object. I'm giving 20 Newton on this side and I'm giving a force of 20 Newton on the other side. So when you have forces in the opposite direction, it's the same. 20 subtracted by 20, resultant force is 0. Same like that. If you wanted to find the resultant moment for this one, what do we need to understand? So how we can find it? So we can say clockwise moment is equals to anti-clockwise, right? So if I take the clockwise moment, let's say this is going to be the anti-clockwise, and this direction is going to be clockwise, and the forces are same. 0.5 equals to 30 into 0.5, because clockwise is equals to anti-clockwise whenever they say the object is at equilibrium. So you have to use so 30 into 0.5 is 15 Newton meter. It is opposite direction. If I subtract it, what will be equals to 0? So which means this is something you have to understand. So earlier I showed you that the object is fixed, but it is not at the equilibrium. But now the object is fixed, but the object is at equilibrium. So whenever they use the word equilibrium, you make sure that the object is rest, which means the clockwise is equals to anti-clockwise. So simply you have to find the values. That's it. Let me show you a question, how it will come to your second term paper grade 10, especially about the equilibrium, or like how they will give a question related to the equilibrium one. So let me show you how that comes. But before that, did you understand? Before that, did you understand? Before that, simply understand the resultant moment of force is 0. Why? Because the clockwise direction is equal to anti-clockwise. So let me give you how they give a question related to your exam, and then I'll give you another question so that you will be able to practice more. So let's say, for example, let's say a rod fixed at, let's say, a rod that is fixed at the roof or top of the roof or something. Let's say it is fixed at the roof. Okay, so now they have given you like this in exam paper, and this is the rod you are having. This is the rod you are having. I'll show you how to do the calculation. And they have said you are giving a force here. Let's say this is the force A. And let me say, and here also you are giving a force B. Okay, you are giving a force B. And they said that for the force A, they haven't given you the force A. They have given, here I have a mass of 2 kilograms. They have given you that for the force A, instead of giving the actual force, I have given you the mass. And then they have said this is 0.2 meter and this distance is 0.5 meter. So what is your question is, they will not ask you to find the resultant moment because they know the resultant moment is going to be 0. They know the resultant moment is going to be 0 because clockwise is equals to what? Anti-clockwise, isn't it? It is going to be equal. Okay, so the main thing is, what is the main thing? The main thing is they will tell you, they will give you the mass this side and they will ask you to find the force at the B. Like indirectly by using one information, you have to find the other information. Like you are going to be like an investigator. So you will have one information. From a small information, you are going to find this information, that information, and finally you will find the main information. So now they are asking you to find the force at the B. So since they have given the mass, can't we find the force of A? Can't we find the force of A? What are the equations we studied to find the force? What are the two equations we studied to find the force? We can remember unit 4, we studied force is equals to mass into acceleration. We studied one equation. What is the one equation? So we studied one equation, that is force is equals to mass into acceleration. Another equation we studied, force is equals to weight, and weight is equals to mass into gravitational force. So that means we don't have the acceleration here. Can we use this equation? No, we cannot use this equation. That means what equation I can use if I wanted to find the force at A? I can use the force number 2. So how I can do? Weight is equals to mass into gravitational force. So what is my mass? What is my mass? Force, what is the gravitational force on the earth? 10. So 2 into 10 is going to be how much? It's going to be 20 Newton. So that means I found the force at the A. Then can't I find the force at the B? Can't I find the force at the B? I can. How can I find it? How can I find it? How? So simply you can use what we can say, the force into distance is equals to force into distance, because clockwise moment is equals to anti-clockwise moment. So we know this is going to be the anti-clockwise moment, and we know this is going to be the clockwise moment. So clockwise moment, what is the value? We don't know the force. Force into distance 0.5 equals to, what is the force here? We found the force, that is 20 into what? 0.2. So 20 into 0.2. So can't we find it? We can simply find it. We can simply find it. What I can do? I can bring the multiplication 0.5 into the other side as the division. So 20 multiplied by 0.2 divided by 0.5. 0.2 divided by 0.5. So you know decimals and decimals cannot be divided. So what we can do? We can jump the decimal. How we can jump the decimal? So if I jump the decimal, these values will be solid. So that means 20 into 2 divided by 5. Isn't it? So if I divide the 20 by 5, that's going to be 4. 4 into 2, my answer is 8 Newton. So that means the force that I'm applying here is 8 Newton. Clear? Got it? Understood? Got the idea how this is working? Got the idea how this is working? Yes? Did you understand? Okay, I'll give you another question. You can try that out. I can give you another question and you can try that out. I'll erase this and you're going to try it, okay? So while you're trying, I will see if the others are having doubt, okay? Right. So let me give you a question. You can do it. This is also going to be same. Let's imagine you are having a rod and this rod is fixed to the roof. You are having a rod and this rod is fixed to the roof. Okay, and this rod is totally 1 meter rod. It is a 1 meter rod. And then let's say you are applying a force. Now this is the axis of rotation, okay? This is the axis of rotation. And you are giving a force of, let's say you're having a mass of 5 kilogram. And let's say this is the force A. And the distance is 0.5 meter. And from the center of this, you are giving another force that's going to be force B. Okay, force B. And let's say this value is 0.25 and here also 0.25 meter. And they are saying that you have to find the force of the B and you have to find the mass of the B, both. You have to find the force of the B as well as you have to find the mass of the B. So by how I did earlier, try to do the question. Once you find the force of the B, automatically you can find the mass of the B using the same equation. So try this out. Try this out, I'll help you. If you're done, let me know. We have a small part of this lesson. Once we are done with that, the lesson is over. Okay, so once we are done with that, the lesson is going to be over. So once you find the answer, let me know. I'll give you just 2 minutes and I'll help you to do how to do this question. Yes. Asma, you can find the just find the mass, okay? Give me the final answer as mass. I told you find the mass. First, you can find the force of this, but the force that you gave is not correct. Just double check, okay? Just double check. Okay, let's do together. First, find the force at A. How can we find? They have given you the mass, right? Weight is equals to mass into gravitational force. So mass is 5 and the what is the gravitational force? 10. So 5 into 10 is how much, dear? 50 Newton. So that's going to be 50 Newton. Now, simply, you know that this object is fixed, right? If it is fixed, clockwise moment is equals to anti-clockwise moment. So how we can write the equation? F into D is equals to F into D. Why? This side and this side, we are making it equal. So we know the force that's going to be 50 and this is 0.5. Okay, right? This is 0.5. And the other side, we don't know the force. We are going to write it as FB. And what is the distance from here? This is the force. This is the force. And this is the axis of rotation. I told you that you take the distance from the place you apply the force to the axis of rotation. So you take it as 0.25. Take the multiplication 0.25 to the other side. So 50 into 0.5. That is divided by 0.25. You studied in maths. Here, decimals and decimals cannot divide. So what can you do? Here, listen to me, here at the denominator, you have 2 digits to jump. If you're jumping 2 digits on the numerator also, you have to jump 2 digits. So that means if I am having here 50 and if I'm jumping here, it's going to be 5, no? Another one more time, if I'm jumping another one more time, there will be a 0 added. So 50 into 50 divided by 25. So 25 divided by 50 is going to be 2 times. 50 into 2 is 100 Newton. So that means we found the force at the B is 100 Newton, right? How can I find the mass? Same equation, use the same equation. Weight is equals to mass into gravitational force. So gravitational force is given. Weight is 100. Mass, we don't know the mass. Take the 10 to the other side. 100 divided by 10 is going to be 10 kilogram. That's the answer. That's the answer. Clear? Understood how to do it? So this is the most advanced part of this lesson that they can even go to ask you about the mass. They can provide you the mass and they can ask you the mass. So you should be able to do everything step by step. So if you don't know, just write it down and keep it. Next time it will be useful for you. So clear? Clear, understood how to do the question? Yes. So now you know that if the object is not fixed, how to find the resultant moment. And then you know that how to find the resultant moment when the object is fixed at a roof. So clockwise will be equals to anti-clockwise if they are fixed to the roof. Clockwise will not be equal to anti-clockwise if they are not fixed, but they are just loosely fixed. They are loosely fixed. They are not completely equilibrium. If they use the word equilibrium, then remember this way. If they don't say the word equilibrium, then remember the other way. We first found the direction, we substituted, and we found the resultant moment. So there are 2 ways in this lesson. The last but not the least that you're going to study in this lesson is couple of forces. Couple of forces. That is the last part of this lesson. So couple, look at the word couple of forces. So whenever you talk about a couple, are you going to talk about one person or two person? Are you going to talk about one person or two person? You're talking about two-person. Are you going to talk about the same type of person or opposite, like girl and girl, or boy and boy, or boy and girl? We say boy and girl. So boy and girl is not same. They are opposite people. So couple of forces also, two forces, and they are opposite to each other. They are opposite to each other. So let's say, for example, you have an object, and from this side you are giving a 10 Newton. You are giving 10 Newton means from the opposite side you are giving a 10 Newton. So that means you will have same value of forces in a different direction. We say opposite direction, the magnitude will be equal. So they will have the same magnitude, but they will have different line of action. They will have what? Different line of action. So they will have different line of action, but the same magnitude. So here, simply understand, couple of forces means two equal forces with opposite direction. They will have two line of action, two different line of action. Let's say, for example, you have an object and that is hung. Okay, that is hung. And from the center of the object, you will have the force called weight, and you will have a force that is on straight of the weight, you will have the tension. So this tension and the weight doesn't have the different line of action. They have same line of action, which means they cannot be considered as couple of force. But couple of force, they will have two different line of action. For example, when you're opening a tap, so here you will push, here you will pull. So push and a pull will happen at the same time with the same magnitude when you open a tap. When you're using a screwdriver, when you're using a steering wheel, when you're opening a bottle lid, you will have the couple of forces. So in exam, they will ask you some examples for couple of forces, and then they will ask you to find the value of couple of force. How to find the momentum, how to find the moment of couple of force. Let me show you how to find the moment of couple of force. Very simple. How to find the moment of force. Let me do. So they have forces from the center, they will have a point. They will have a point, okay? So we rotation, but remember, if you have a force from this side, you will also have a force from the other side, two opposite direction. So here it will be 5 Newton means, here also it will be 5 Newton. But they will give you the distance in different values. 5 meter, let's say here, 2 meter. So how to find the moment of couple of force? Simple. You have to add the distance, add the distance. You have to add the distance and multiply by one single force, because both of the forces are having the same magnitude, right? So you don't want to use it twice. You will use it only once. So what you will do? 5 plus 2 is 7 multiplied by 5 Newton. So 7 into 5 Newton is how much? That's going to be how much? Yes, 35. It's going to be what? 35 Newton meter is going to be the answer. So you can do it in another way. There's an alternative way also. So there's an alternative way. 5 into 2 plus 5 into 5, you can do like this. So that means 5 multiplied by 5 meter. 5 Newton multiplied by 5 meter is, you can take it as 25 plus 25, you can take it as 35 Newton. These are the two methods we use to find the couple of force. So couple of force will be always same. It will not come in a different way like we did earlier. So here, just add the distance and use one force to multiply. Simple. You can find the couple of force. Clear? The moment of couple of force, you should know the examples. You should know how to calculate it. That's it. That comes under the lesson number 11. Got it? Clear? Right. So we are done with the lesson, and you can do the model paper as a homework, so that if you find any difficulties in doing that, you can contact me to this number. I will help you to the maximum. So you can contact me. And also we usually have our grade 10 classes on every Thursdays, 6:30 p.m. to 8:30 p.m., which is probably 2 hours. And then we complete the lesson before your syllabus. I mean, before your second term, third term, we complete your syllabus. And every Fridays, we will have the revision classes. We will have the revision classes every Friday, 6:30 p.m. So whatever you studied today, we will do it as a revision next. Like, let's say today we completed this lesson, right? So tomorrow we will do revision. For example, I have provided model question, past paper question, revision question, quick revision questions, like around 5 papers, like around 5 PDF I will be providing for each particular lesson. So that means we have it as a book for the students as a PDF. So we will be doing maximum practices in the classes. So you will be practicing more as well as you will be preparing for your exams. And we will be doing a lot. For a month, you will have 8 classes, not 4 classes, 8 classes per month. You have to just pay 2,200 only. So yes. So in my class, just 2,200, 8 classes per month. Okay, so 8 classes. So one day completely you will have the theory. Another day you will completely have the revision. So whatever you covered today, you will be covering as a question, revision, past papers tomorrow. So this will be done. Okay, so I also have the term papers. We do term papers, past papers. We do all level past papers also. So every questions are covered in every part of the lesson. See you in the next class. And if you're interested to join, you can just drop me a text. And yes, you can have the recording. We have the unlimited access of recording. So from the beginning, from lesson 1 to the lesson that we have completed today, you can get access to all the recordings, all the short notes, all the past papers, everything will be given. So you don't want to pay extra for whatever you have been missed in the last class. Okay, I'm teaching for grade 10 and grade 11 also. So for the grade 10, we are moving with the unit 12 for the next week. And for the grade 11, I'm moving with the unit 10 with the next week. So almost we are up to the date we are going to complete the syllabus. Like we have only 2 lessons to complete for the second term syllabus. And then we will be having more practice questions and everything. Okay. Then see you. Good night. Have a good day. Thanks for joining. Thanks for your support. Take care. And if you have any doubts, you can ask me.